Okay, we are doing 8.3 today. There's not a title, but I'll tell you what we're learning about is the same stuff that we did last time, 8.2, which was AA similarity. This time we're going to do SSS and SAS similarity. That's what we're doing today. Use the diagram to copy and complete this statement. Bless you. So we need to figure out what triangle is similar to A, B, C. I think, nope, I'm wrong. There isn't missing information. When we look at this, let's kind of use each other, talk about what we could see or mark, or do you want me to randomly call on you, or do I have some people to volunteer their ideas? Lynn, you got an idea?
Well, I know that I see two right angles, so the right angles is 0.
Okay, we actually see 3 of them, right? Yeah, so this is congruent to this one, and which is also congruent to this one. So we've got one angle that is congruent in 3 different triangles. Somebody different. Or I can randomly call on you.
To see if they're similar, we should just like get a piece of paper and trace it and turn it around.
We could, but we're doing it. I got this is stuck in my hair. Okay. That could be one way of doing it, but we are going to use the theorem angle, which I know that you were ahead in your other class. Like, I mean, you guys already did this. So, am I correct? You've already done angle.
I don't know.
Okay. Well, it doesn't matter then. So we're going to use a theorem angle, and to use the theorem angle, we have to show that there's 2 angles that are congruent, and then we know they're similar. Do you have an idea, Alex? Hold on. ACB and what? ECD. Why are they congruent? That's correct. They are congruent. Because they're vertical angles. So right now, I do know that triangle ABC is similar to this triangle I'm outlining in blue, and J is going to tell me the name of that triangle that I just outlined. Just gave you a hard job, Jay. What's the name of the triangle in blue? I'm sorry, I didn't hear you. CDE. Okay, so I'm going to say that is the name of the triangle. However, when we name this triangle, we have to name it in the order that A corresponds to what angle? Does A correspond to angle C? No. So what's angle A correspond to? Did you say D? Okay, so D. And then angle B is going to correspond to which angle? To E. And then that means angle C corresponds to angle C, right? And then that is by angle. Because we found 2 angles that are congruent. All right, and then now FEG. FEG, that one I'm going to color in yellow so we can all look at it. FEG is similar to what triangle? Who has an idea? I'm gonna bounce off of Lynn's original idea. We have a right angle that starts the process. Yes, John. CED. Is it CED? But why? Okay. Oh, angle E. So if angle E is the same angle for both triangles by reflexive property, right? Then we have two angles that are congruent. Yep. So triangle FEG is congruent to, can you say what you called it again? CE. That is correct, CED. And then that's also by angle. Okay, so our new theorems today. We're going to have a theorem that is side similarity theorem. And this theorem says if we write the proportionality statement, if we write all those sides that are similar and corresponding on top of each other, if they all have the same ratio, then we can say that these are congruent. So we're going to prove that all three sides are proportional. Not congruent, I meant similar. Triangles will be similar. If all three sides are proportional, then the triangles are similar. So here is either triangle DEF or similar to triangle ABC. So I'm going to start with ABC. In order for it to be similar, then we need to have like AB, BC, and AC. We're going to fill in the numbers in a moment. We have to have all of those. It can be either all three tops or all three bottoms. It doesn't matter which one it is. But we need to have all of those equal. Now we have to see if that works for either triangle DEF or triangle GHJ. I would definitely look to see which one looks more like it's going to be before I just start randomly throwing numbers in there, because we got to check both of them, and if we find the right one first, maybe less work. So I'm going to put AB, BC, and AC on the bottom. Oop, I'm not putting AB. Sorry, I'm putting the length of AB. Let's see, AB is 8, BC is 12, AC is 16. So we're going to put those three on the bottom. You guys, which one do you want to try next? DEF or GHJ? DEF? Oh, all right. Okay. So now we got to figure out what is going to correspond to AB. So I'm going to look here. AB in the directions are the first two letters. So if we're doing DEF, what should correspond to AB? It should be DE. They're in the same order. So let's see, DE is 6. Let me put that on top. And now BC. So what up here, BC are the second two letters, or the last two letters. Over here it would be EF. So EF is, and then 12 would be the last one. Let's see if these all equal the same number. I reduce 6/8. What do I get? 3/4. 9/12. 3/4. 12/16. 3/4. So yes, we can say that those two triangles are similar. Just in case they're playing a trick on me and there's more than one answer, just in case. Let me check a side. Let's see, maybe I'll check GH with AB. There's GH. 8. If I did GH over AB, oh, I'm off the screen. If I did GH over AB, does that also equal 3/4? No. So right there I can tell you it's definitely not that one. So triangle ABC is similar to triangle DEF. It's good to write it twice. This should be easy stuff. Am I going too fast? I know some of you are still writing. If you're sitting really close to somebody with a stylus and they're not using it at the moment, you could always grab it real fast and write some stuff down. If you want. If they're nice to you and let you borrow it. Remember, you can always get a new stylus. Go on the internet and buy some, or you can buy one from the, where do you go? The Hub? Is that where they sell the new ones? Can we take attendance?
Staff, please take attendance at this time. Please take attendance at this time. Thank you.
Already did it. All right, find the value of x that makes triangle ABC similar to triangle DEF. So again, AB corresponds to DE. That's how I know for sure what I put on top of each other. So AB would be 4 and DE would be 8 or 12, sorry. So 12 goes to 4. BC and EF, so 18 goes to x minus 1. And we have 3 multiplied by x plus 1 goes to 8. Now you cannot cross multiply 3 things. I wrote them all 3 down, but we can't cross multiply 3 things. Use 12 over 4 for sure, because that has both numbers. Would you like to use the second fraction or the last fraction? When we cross multiply, if you have multiple terms like x minus, you have to distribute. And 4 times, I don't know what 4 times 18 is. Is it 36? 70? Yeah, I think it's 72. Do you do it by hand? Me too. Hopefully we're right. Move it over here. We've got 12x 12 equals 72. Add for 12x equals 84. Divide by 12. And x. Am I right? X is 7. Is that the? What if I made a mistake? Is there any way to kind of check that I did make a mistake? I could plug it into the one just to make sure. 3 times 7 plus 1. What is that? 3 times 12 over 4 should equal 24 over 8. 12 over 4. What's 12 over 4? 3. 4 over 8. Okay, so that we've done it right. Halfway done. I'm going to stop. This is a you try. It says which of the 3 triangles are similar. It's a little tricky because it does not give you the letters in order. So you're just going to have to kind of figure out which ones could possibly match up. I got an idea for you. Look at the lengths in LMN. Which is the shortest length? 20, and then 24, and then 26. So if you look at 24 is the shortest, then 30, and then 30. So I'm telling you which sides would have to correspond to each other if you just look at their lengths. 30, then 36, and then 39. That should give you a hint of which ones should correspond to each other. You're figuring out which ones are similar and writing the similarity statement. Oh yeah, the other thing is if you don't want to do it, I'm just not printing out all the paper anymore. I feel like it's wasteful. You won't use it, but we'll figure it out.
What's your figure number? Like, if it's
Okay, so we are doing kind of like what we did for this one. It's a lot like this one, only like this one it told you the names of the triangles. Each other.
okay.
So the reason why I said 1, 2, 3 is because for this one.
Okay.
So between these two triangles, what are the two shortest lengths? 20 and 24. So put what are the medium twos? The twos.
Well, the third one. Try the third one.
Okay. And do them all equal the same number if you reduce them. Or you can type in your calculator. You have your calculator with you. Well, then you can't do that. Or you go to the internet and get a calculator. Holding this thing on. So you guys, I haven't said that you can't use a calculator if you're having trouble with reducing. You're more than welcome to try using a calculator. I didn't do it myself yet. So, if they all equal the same numbers, then yes, those would be right. Okay, I'm going to do the work on the board as well. I know some of you are still catching up. Okay, so if I'm checking these first two triangles, I'm going to do 20 over 24 has to equal 24 over 30 has to equal 26 over 33. And I either reduce those by hand or I pull out a calculator and find a decimal. But since I am the teacher, I guess I'll reduce them by hand. Set good examples, right? Like, I found 2 of them, and they're not the same. So I can just stop. I mean, I can find the third one. So that one doesn't even reduce. So I know that these two are not similar. You could do 24 over 20. Yep, either way. As long as you have the same triangle straight across from itself. Okay, maybe I will look at these two. I have 24 over 36, and then I have 30 over, oh, I did the wrong one, sorry. This is 24 over 30, 30 over 36, and 33 over 39. I reduced 24 over 30, that's 4/5. 36 over, or 30 over 36 is 5 over 6. So maybe it's the last two that I didn't try yet. Of course, isn't that the way it goes? It's always the last ones you try, right? No? Just me? Okay. 24 over 36 and 26 over 39. I reduce those, I get 2/3. 2/3. So I know it's the first triangle and the last triangle. Now we have to write a similarity statement. So the similarity statement is writing which triangle it is. So if I go LMN, long side, then I would do the same thing with XYZ. I'm going to go from the short side to the medium side. So that would be triangle Y, Z, X. Did I do that correct? Short side, yeah. So that would be the last one. Can you put the letters in order? They don't always go alphabetically. Questions on this one? Did this take a little bit? Yes. Was it difficult? Nah, it wasn't too hard. Especially if you can use your calculator if you're not that great at simplifying fractions. All right, we have one more theorem. This last theorem is called side angle side similarity theorem. So the angle means that we have one angle that we know that is congruent. And the side around that angle means the two sides. What are we talking about? Not congruent. What are we talking about? The corresponding angle at the two sides that make that angle are proportional. So your building starting from a tree. This is a little hard to see, but here's your tree, and these similar triangles. So first of all, are the angles congruent? Why? Because they're both 53. Proportional with side. Oh, that's not either. It's enough. So side FH bond and be proportional with side AC. Over 9 has to equal 10 over 15. Does it? Oh. So if I reduce 6/9, I get 2/3. If I reduce 10/15 by 5, I get 2/3. So these, yes, these are similar. All right, the last is explain how to show. So now we're going to use things like you're doing proofs. We're going to explain how to show that these triangles are similar. So angle R is congruent to angle N. Lynn said it earlier. Does anybody else besides Lynn, because I know Lynn knows the answer, Can anybody else tell me why these two angles are congruent? Rakaya? That is true. They're both right angles. What is it, David? The right angles congruence theorem. Right angles congruence theorem. That's the theorem that says the right angles are congruent. Okay. Now, I only have one set of angles, so now we are going to use SAS to see if, or actually it says explain, show. It says to explain and show how they are, so we already know they are, but we're going to use SAS. And 20 compared to 18, or correspond with. So then 28. So again, you can use your calculator. I'm going to reduce 24 and 18 by 6, and I'm going to get 4/3. I'm going to reduce 28. 4/3. So then we will say this is SAS. All right, this one up here says XZW, XZW, this medium triangle, and then Y. How could we try this one? Who has an idea? Ryan, you have an idea. I know you do. You're waiting to say it. XZ correspond to XZ. Do you see where I just pointed? Does XZ correspond to XZ? No, so we're not going to look. Now, if we were doing congruency, definitely. That's okay. Yeah, so they both are right. They both are right, aren't they? So we can have, well, let me see what she said again. XZW is congruent to angle, what was, so I'm going to write YZX because we want the corresponding ones to stay together. It's the same angle, but, and why are they congruent? I was like, it's right here. Right angles, congruence theorem. All right, and then if we've got two angles congruent, then what do we need to do from there? Aaron, if we have two angles congruent, what else do we need to do? We need to show that we have some proportional sides. So when we look up here, I need to use ones that coordinate or correspond to each other. So if I am using XZ, which I already underlined, so I'm going to use it. If I'm using XZ in the medium triangle, then what do I need to use in the small triangle? YZ. So if I do 20, I need to correspond that to 9. Not 20, I'm sorry, that's 12. I looked at the wrong one. Now that should be the same amount, so we've used this side. We need to use the other side that makes that 90-degree angle. So Cameron, in the medium triangle, what's the other side length that I need to use to make that 90-degree angle? Just tell me the number. Okay, so you're looking in the wrong triangle, hon. I'm looking in the triangle on the left. We need to use the two sides that make up this 90 degree, and I've already used the one I've made really dark blue. So what's the other one that makes up the... No, because the angle is not between those two sides. The angle is not between this side and this one. The angle that I have, 90 degrees, is between the 12 and the 16. Can you see how these two... But, oh, it looked like 15? Okay. Yeah. You have it in front of you, though, don't you? Okay. So we're going to use these two sides. So 16 is going to be on top. Now, in the other triangle, same thing. We used the 9. I'll do that in a different color. We used the 9 already in the other triangle. So, Jay, which number should I use in the second triangle? So I want to use the angles that's right angle. I just wrote down 9. It's confusing. I've already written down this number. It is 12. But 12 is in both triangles, like Ryan had mentioned earlier. So let's see if these are equal. So if I divide 12 and 9 by 3, yes. Last question. Was that the only way I could have proved Matthew? It's SAS. Okay. Did I know all 20 over 15? 20 over 15. They had both options for you. Okay, this assignment should not be too difficult. Forgive me, I didn't type it in Canvas yet. It's in right now. Sure of it though, because I had to give it to somebody yesterday. And I'll just make sure that you know how to do that if you haven't done it before. You guys have about 8 minutes where you can pull it up and start. You'll be doing it on your own paper.